Hello and welcome to this session everyone. My name is Yogesh Mehta. In last couple of videos on Docker, we have talked about Docker basics, how to create Docker image and how you can customize Docker networking. This session is going to be on Docker Swarm. We will have a quick introduction to Docker Swarm and then the basics of this particular Swarm mode. So guys, let's begin. So Docker Swarm. Swarm is native clustering for the Docker. In the context of Swarm, a cluster is a pool of Docker hosts that act as a bit like a single large Docker host. You can also run Swarm services and standalone container on the same Docker instance. What cluster mean? Cluster mean you can club multiple hosts to make a single entity. And what the benefit cluster can give you. It can give you fault tolerance, it can give you redundancy for your services, it can give you better management of your Docker containers. So you can manage your Docker containers in an organized way with the fault tolerance, redundancy. I've listed a couple of features of Docker Swarm. Swarm setup is very quick and easy. No separate infrastructure requirement at all. And the Swarm itself ships as a standard Docker image. So that's again a beneficial thing. Swarm implements most of the Docker API endpoints, which mean tools built on it can work out of the box. Swarm supports affinity definition and configurations, which mean Docker Swarm will launch a container only on a Docker host that does not already have same container or same application container already running on it. What it mean, guys? Affinity mean let's say we got two node cluster and we got two application virtual servers or containers. If I put both the application containers on single host and that host dies or get some fault, what is going to happen? Outage, because other host is healthy but our application, both containers were running on single host. When we apply affinity rule, what it mean? At a time, one container will run on one system, other container will on other. In case one system get fail, at least we will have other system running, which mean there may be impact for sure, but impact would be less. So that's a benefit of affinity, and Docker Swarm supports affinity definitions. Next feature, Swarm supports high availability. We can join multiple manager nodes to the cluster. Maybe you will be thinking, what is manager node now? This is something I am going to cover. You can say at this point, manager node is a node which manages all the cluster components. So that if one manager node fails, another can automatically take its place without impact to the cluster. So that's again beneficial, high availability. Swarm supports scaling. For each service, you can declare number of tasks you want to run. When you scale up or down, Swarm Manager automatically adapts by adding or removing tasks to maintain the desired state. Scaling, if I have to explain in simple words, let's say you have defined your application that it need to be running with 2 containers. But now load on your application is high and you want to scale it up, means you want to add some extra containers. So you can simply change the definition of that service saying I need 5 instances. Then Docker will automatically kick off build of remaining 3 instances your application will be running. This is called scale up. Another example, let's say you got 5 containers and load is not that much high and you are thinking let's reduce or scale down this particular application service definition. You put 2 containers instead of 5, then automatically Docker Swarm will delete the remaining 3 and it will maintain the desired state. Like whatever your desired state, basically that's your input to Docker. Swarm support network overlays. Network overlays are used when multiple hosts are communicating with each other, multiple nodes basically. The Swarm Manager automatically assigns address to the container on the overlay network, which it initialize or update the application. Swarm is secure by default. Each node in the Swarm enforces TLS mutual authentication and encryption to secure communication between itself and the other nodes. Security is main thing, so Swarm is secure by default. Rolling update is another good feature. At rollout time, you can apply service update to nodes incrementally. So that's beneficial thing. On my screen, you can see I have listed like how Docker work in traditional way and how Swarm work. If you see on screen this particular Docker host, we are communicating with Docker CLI when we want to spin up a container. In this example, we got 3 Docker hosts. Let's say this particular host is running this Linux container and this host dies or gets some hardware fault or any other issue. What is going to happen? This container is going to die. Means whatever application was running, we have to manually create that application on some healthy container, which need manual effort. That's a traditional mode. In Swarm mode, what happens? We club all the Docker host as a combined entity under a cluster, and the 4th node, which is our Swarm host in this example, that is managing all the host, and we are only interacting with the Swarm host, or you can say Swarm manager, and this manager sent instruction to this particular host, like create this Linux instance, do this. In this example, let's say this particular host dies. What is going to happen? Swarm manager will automatically check the status. Okay, this particular host is not responding. Then Swarm manager will start or the build of similar container on this particular healthy node, this one or this one. How Swarm picks like which node to pick for the container host? Basically, it checks what's the load on existing system and what are the affinity rule. There are another main things, but I'm just going to cover basics. Again, repeating, you will be interacting with the Swarm node using CLI or API. So that's a difference between traditional mode and Swarm mode. I'm sure you would be happy like Swarm mode is far better than the traditional mode. Now, to understand Swarm, we need to understand its key concepts, because key concepts are the main building blocks. If we understand those, the next learning is going to be easy. So first, manager node. Manager node manages the application deployment of the request task which manager node performs. It dispatch unit of work called task to the worker nodes. Means it sends instruction to the worker node. Worker node is basically Docker host, which will be running containers or the services. Manager node is who manages everything, who sends instruction to the worker nodes. Manager node checks that desired state of the Swarm. So as I mentioned in my last example, manager nodes always checks the particular container which is running on Docker node 1 example, that is running or not. In case it is not running, Swarm will automatically try to start it. If not starting on that particular node due to some issue, Swarm will kick off build on some other healthy node. Manager node elect a single leader to conduct orchestration task. The term leader mean when we got multiple manager nodes, more than one, then one node will become leader and Swarm automatically elects a single leader, because at a time you will have single leader, other will be manager, still manager, but they will be not leader. Leader is only one who is the main entity in that particular cluster. Manager node keeps track of resource utilization on the worker nodes. So it checks, okay, how much a particular node is utilized. If node is heavily utilized, Swarm will not kick off any new job built on that particular node. So next thing, worker nodes. Worker nodes are basically the host. Let me go to previous slide quickly. These are the worker nodes. This is worker node, this is worker node, this is worker node. And this particular node is Swarm manager. Worker nodes receives and execute tasks dispatched from manager node. By default, manager node also runs services as worker node. but you can configure them to run manager tasks exclusively. So I'm repeating, manager node itself acts as worker node too, but you can change the definitions. You can perform the tuning where you will restrict manager node to act as a worker. An agent runs on each worker node and report on the task assigned to it to the manager node basically. The worker node notifies the manager node of the current state of its assigned task so that manager can maintain the desired state. So worker node sends all the updates to manager node. Next important thing is service. So guys, service is the definition of the task to execute on the worker node. It is the central structure of the Swarm system and primary root of user instruction with the Swarm. When you create a service, you specify which particular container image to use, which command to be executed inside the running container, what is going to be ports which will be exposed, what is going to be port forwarding. So these are the configurations which are saved inside service. Also in service you mention the replicas, like how many instances of that particular application you want. When I say instances, those are basically containers. Let's say you want to run 5 containers, you set replica is equal to 5. I will come to that when I'm giving technical session in next video. Next important thing is task. Task carries a Docker container and the command to run inside the container. It is the atomic scheduling unit of Swarm. Manager node assigns tasks to the worker node according to the number of replicas set in the service scale. So replica is basically number of instances which we set in the service. Like these many instances need to be in running state. Once a task is assigned to a node, it can't move to another node. It can only run on the assigned node or fail. This is something, let's say you have kicked off a build like on this particular node, this particular container to be created using Swarm. In case that node dies in between the container creation, the task will fail. If task is already completed, that is a running node or running application now. In case that node dies, then Swarm will kick off the build of similar image on other node. Next thing is load balancing. The Swarm manager uses ingress load balancing to expose the services you want to make available externally to Swarm. The Swarm manager can automatically assign the service a published port in the range of 30,000 to 32,767. Otherwise, you can choose your free ports in your network. Next is DNS component. DNS component automatically assign each service in the Swarm a DNS entry. The Swarm manager uses internal load balancing to distribute requests among services within the cluster based on the DNS name of service. So guys, these were key concepts of Docker Swarm. In next video, I'm going to demonstrate how you can go in to create a Swarm cluster in easy steps. So stay tuned. Thank you guys.